Welcome to the deep dive. Look, if you're operating any kind of online presence today, maybe a simple blog or a huge e-commerce platform, you probably feel like you're constantly playing this high stakes game. The internet, well, it's kind of a battlefield, isn't it? You're constantly barraged by malicious bots, sophisticated fraud attempts, and these crippling distributed denial of service or DDoS attacks. Honestly, staying protected feels less like a task and more like a never-ending war. So, our mission in this deep dive is to try and simplify and clarify the powerful arsenal AWS provides for exactly these challenges. We're talking about AWS WAF, AWS Shield Advanced, and AWS Firewall Manager. Think of it as getting the ultimate tactical guide, maybe a cheat sheet, to navigating this crucial security landscape. We're going to break down how these tools work, why they're pretty much indispensable, and most importantly, how they all fit together, how they form this robust, multi-layered defense for your applications.
It's absolutely true. The threat landscape isn't just complex, it's constantly evolving. That makes understanding and, implementing these services not just beneficial, but really necessary for anyone building or operating at scale in the cloud. And these aren't just isolated features, they offer a truly multi-layered defense. We're talking from inspecting individual web requests all the way to absorbing massive volumetric attacks before they even, sniff your application. While the tech underneath can seem a bit daunting, we're going to try and uncover the core concepts and those critical aha moments. The things that will leave you feeling truly well-informed about how to secure your digital assets effectively and proactively.
Right, proactively. And just so everyone knows, to ensure drawing directly from the most accurate and authoritative source for this deep dive, we're pulling all our insights straight from AWS's own comprehensive documentation. So let's get into the trenches. Okay, let's dive into our first major line of defense, AWS WAF. What exactly is AWS WAF? At its core, it stands for Web Application Firewall. Now imagine your web application is like a bustling popular club. AWS WAF acts as its highly configurable personal bouncer. It stands right at the entrance, diligently monitoring every single HTTP and HTTPS request, trying to get into your protected resources. Its job, based on the rules you set, is basically to decide who gets to step inside and who gets turned away at the door.
Yeah, and what's really remarkable is WF's adaptability, its sheer versatility. It isn't just stopped protecting one type of application or service. It acts as this consistent protective shield across a really vast array of your AWS resources. Think of pretty much anything publicly accessible that handles web traffic within AWS. Your website's fronted by Amazon CloudFront distributions, obviously, but also your Amazon API Gateway REST APIs, your application load balancers directing traffic, AWS AppSync, GraphQL APIs for those building modern data-driven apps, even things like Amazon Cognito user pools, managing identities, and newer services like AWS App Runner and AWS Verified Access instances, and definitely AWS Amplify applications. So this means you can apply a consistent security policy across your entire web application footprint within AWS, regardless of the underlying architecture. That consistency, that's a huge advantage.
Okay, so when you're setting up this bouncer, this Dovet, there are three core building blocks you absolutely need to get your head around. First, you have Web ACLs. That stands for Web Access Control Lists. This is the central control point where you define all your protections. Think of it as the bouncer's master rulebook for the whole club. Then inside that rulebook, you define your rules. These are the individual instructions, the specific criteria WEF should inspect in a request, and the exact action to take if a request matches. And finally, you could organize these individual rules into rule groups. These are essentially prepackaged security playbooks, which lets you organize, reuse, and even share sets of rules across different web ACLs or applications. Makes things way easier to manage, right?
Exactly. And if we sort of connect this to the bigger picture, it's really worth highlighting the significant evolution from the older AWS WAF Classic to the current AWS WAF. The newer version isn't just an update, it's more like a foundational shift. Imagine moving from a defense that was largely reactive, maybe a bit rigid, rule set driven, to one where your firewall is highly programmable, almost like security as code. This shift enables a truly proactive posture where you can rapidly adapt to new threats and integrate security deeper into your development pipeline, not just, bolt it on at the end. For instance, rule writing is now document-based, using a more streamlined JSON format. That simplifies configuration, maintenance. It makes it much easier to manage rules at scale through automation. You also get enhanced capabilities like rule nesting for really complex logical operations. Think something like A and D, not B or C. This allows for much more sophisticated filtering, much more precise threat identification. Rate-based rules have also seen significant enhancements. They allow WAF to react more quickly, more intelligently to sudden spikes or changes in traffic patterns like you might see in a distributed attack. And it's important to understand AWS Wave Classic is nearing its end of life. Migration to the current AWS Wave is strongly recommended, not just for continued support, but really to leverage this enhanced programmability and agility. That's the true superpower of the new Wave, I think.
Okay, so what does this all mean for you, the listener? Whether you're a developer, an architect, or a security pro. This distinction between Classic and the current AWS WAF isn't just about a version number, right? It's about having access to far more flexible and powerful security configurations. The improved console experience helps too, making it easier to manage these sometimes intricate setups. But the real win, I think, is the ability to automate, to version control, and integrate your WAF configurations directly into your CI/CD pipelines. It's about giving you greater control, better tools, and yeah, that agility to stay ahead of the attackers in this constantly changing threat landscape.
Okay, let's dive deeper into the granular power. Let's explore AWS WAF rules themselves. These rules are where you define the precise inspection criteria and, crucially, the corresponding actions for your web requests. First, you need to tell WAF what to look for. We call this match criteria, and WAF is incredibly versatile here. It can inspect all sorts of components of a web request. This includes the URI, which is, the path to your resource, the query string, those parameters after the URL, various headers like the user agent to see the client's browser, the refer header to see where the request came from, the HTTP method get, post, put, delete, etc., which can be critical for blocking unauthorized operations. And even the request body itself, whether it's plain text or structured JSON. Oh, and can also inspect the size of any of these components too. Now, what's also crucial, especially for catching sophisticated attacks, is the concept of text transformations. See, attackers often try to hide malicious code. They might encode it, obfuscate it in various ways, maybe URL encoding characters or using double spaces, things like that. So before WAF even inspects a request component against your rules, it can apply these transformations. For example, it can convert everything to lowercase, normalize white space by removing extra spaces, or URL decode encoded characters. This helps WAF see the true intent of a request, preventing simple bypasses. And if you specify multiple transformations, WAF processes them in the order you list them. So you can have this sort of pipeline of cleansing before the actual inspection happens. Right, let's look at some specific rule types, these match rules, that define what WAF is actually looking for. The IP set match is a fundamental one. It lets you block or allow requests based on specific IP addresses or entire IP ranges. And these ranges can be incredibly granular. You can block a single suspicious IP or a whole network block, IPv4 or IPv6. The key is that precision. What's really important here, especially if your traffic passes through proxies or load balancers, is that WAF can be told to use forwarded IP addresses. Usually these are found in the x-forwarded-for header, rather than just the IP that connects directly to AWS. You can even configure fallback behavior. Like, what should WAF do if that header is missing or malformed? Should it match or not match the request in those ambiguous cases? You get full control. Then there's the regex match rule. This is super powerful for inspecting requests for specific patterns using regular expressions. It uses the PCRE standard Perl-compatible regular expressions, which is widely adopted, very flexible syntax for pattern matching. You might use this to look for specific attack signatures that aren't covered by predefined rules, maybe, or to identify unusual request patterns that could indicate reconnaissance. The size constraint rule lets you block requests if a component, say the request body, headers, or cookies, goes over a specified size. This is useful for preventing oversized payloads that might be part of an attack trying to crash your server or just exhaust resources. But it's important to be aware WAF does have limits on how much content it can actually inspect within oversized requests, especially the body. It'll typically only inspect up to a certain byte limit, like maybe 64 KB for JSON or plain body components, when looking for attack signatures. Anything beyond that might not be fully inspected by rules like SQL injection detection, though the size constraint rule itself would still apply if the total size limit is breached. And for common web vulnerabilities, WEF offers these specialized attack rules. The SQL injection attack rule detects malicious SQL code. Stuff attackers might use to mess with your database or steal sensitive data. You can configure this with low or high sensitivity levels. Low is less stringent, fewer false positives, which might be better if you have other SQL protections elsewhere, or if you really can't afford to accidentally block legitimate users. The high setting is more aggressive, offers broader protection, but higher chance of false positives. Similarly, the cross-site scripting XSS attack rule inspects for malicious scripts embedded in requests. These aim to exploit vulnerabilities in user browsers, maybe leading to session hijacking or data theft. And for just general string matching, the string match rule can look for exact string matches, or strings appearing at the beginning, end, or middle of components. You can even set specific character requirements for the match. For instance, you could say a string must be preceded or followed by something other than an alphanumeric character or underscore to match. Helps catch specific command sequences.
Okay, this is where it gets really interesting, right? This is where the bouncer makes their critical decision. The rule actions. Once a request matches a rule, WF needs to know what to do. The most straightforward actions are allow, obviously meaning the request goes straight through to your application, or block, which stops the request dead in its tracks. Simple enough. But with block, you have incredibly flexible options. You can even specify a custom response, like you can send back a particular HTTP status code, maybe a 403 forbidden. You could add custom headers to the response, or you could redirect the client to a custom error page that actually matches your application's branding. Looks much better. It's important to note, though, Wave custom responses, if you define them, will override any Cloud Grunt custom error pages you might have set up for that specific HTTP status code. Wave takes precedence there. But Wave gives you more nuanced, sort of tactical options, too. The count action, for example, is incredibly valuable, almost indispensable for security teams, I'd imagine. It means Wave will just increment a counter for requests that match the rule, but it won't actually block them.
I can just imagine how much stress that relieves for security teams, right? Letting them fine-tune rules without accidentally blocking legitimate users. Is that feature often a customer favorite?
Oh, absolutely. It's fundamental for safe rule deployment. It's invaluable for testing new rules without impacting your production traffic. It helps you identify potential false positives or maybe unexpected behavior before you flip the switch to block. It lets you refine your rules using real-world traffic data, see the impact, observe the patterns before you enforce anything.
Okay, and then we have the really intelligent actions, KPTCHA and challenge. These are designed to intelligently distinguish between human users and automated bot traffic. Smarter stuff. They do require HTTPS and JavaScript to function because they present either visual or audio puzzles, that's the KPTCHA part, or these silent challenges that are much less intrusive for the user but still verify legitimacy. Upon successful completion, these actions issue a token. This token is then used in subsequent requests to prove the client is legitimate. It's important to know, though, there are additional costs associated with using these KPTCHA and challenge actions. They involve more complex processing and verification, so that makes sense.
Right. And if a token is valid, these actions essentially act like a count. They let the request pass that check and allow further rule evaluation down the chain. But if the token is invalid or expired or missing entirely, they terminate and block the request. They might issue a new KPTCA or silent challenge to try and re-verify the client at that point. Now, when it comes to how these rules are actually applied, rule priority and the evaluation order are really key to understanding Wave's logic. Rules are evaluated based on a numeric priority. Lower numbers get evaluated first. So a rule with priority 1 will be checked before a rule with priority 10.
That makes sense, but what happens if a request matches multiple rules? Does it just stop?
Good question. A rule that explicitly allows or blocks a request will terminate any further evaluation for that specific request. That's it. Done. This is critical for performance and also for making sure your most important allow or block rules always take precedence. However, and this is where count comes in again if a rule applies a count action, Wave continues to inspect the request against subsequent rules lower down in the WebACL priority list. This behavior is incredibly useful for effective testing and fine-tuning your Wave protections. It lets you see how different rules would affect traffic without actually blocking it initially. Gives you invaluable insights into potential overlaps or conflicts between your rules.
So what does this all boil down to for you, the builder or the security professional listening? It really translates to incredibly granular control over your web traffic. You're not just throwing up some generic firewall. You're tailoring protection precisely to your specific application's needs. Whether that's blocking known bad actors based on IP, mitigating specific attack vectors like SQL injection, intelligently distinguishing human users from bots, or even allowing specific partners while blocking others, W provides that surgical precision over who gets to interact with your application. It truly enables, well, precision security.
And what's fascinating here is how WAF organizes and leverages these rules through AWS WAF rule groups. These are basically reusable sets of rules, which is fantastic for consistency and keeping things modular. They don't actually have default actions themselves. Instead, the individual rules within the group inherit the action from the main WebACL they're part of, or you can explicitly override individual rule actions within the rule group itself, giving you that flexibility. This allows for these modular, shareable security policies that you can deploy consistently across different applications or maybe different environments, like staging versus production.
Right, and this brings us neatly to AWS Managed Rules for AWS WAF. These are curated rule groups provided and maintained by AWS itself. They offer protection against common vulnerabilities and just unwanted traffic. It's kind of like having AWS's own team of global security experts pre-write your rulebooks for you, incorporating their vast threat intelligence. They save you a huge amount of effort and provide immediate baseline protection, which is great. For example, there's the core rule set, CRS, which protects against common exploits like local file inclusion, LFI, and cross-site scripting, XSS, very standard stuff you need to block. There are also groups like admin protection for common admin path vulnerabilities. OS-specific protections for Linux or Windows may be detecting suspicious PowerShell commands, for example, and even specific PHP application rule sets. Plus, you have various IP reputation lists designed to block known malicious IPs, anonymous proxies, or even traffic from certain hosting providers that are less likely to be sourcing legitimate end-user traffic.
And those IP lists often evaluate the source IP from the web request origin. But remember, if traffic is routed through proxies, the rule might just see the proxy's IP, so you need to account for that, maybe using that X-forwarded for header logic we talked about.
Yeah, good point. And it's also worth highlighting that AWS deploys changes to these managed rule groups in versions. They have release candidates for testing, static versions, and default versions. A static version, once you deploy it, is immutable. Its rules won't change after you activate it, which gives you predictability. But the flip side is you need to stay informed about updates and test new versions that AWS releases to get the latest protections. For example, a rule might detect generic Alfura path that'll block requests where the URI path contains LFI exploits. Pretty straightforward. Similarly, the restricted extensions URI-path rule blocks requests where the URI path contains unsafe system file extensions like .log or .ini, which attackers often target.
And beyond AWS's own managed rules, you can also subscribe to AWS Marketplace rule groups. These are managed rule groups provided by trusted third-party security vendors available right through the AWS Marketplace. They often offer more specialized protections, maybe tailored to specific threat intelligence feeds or industry needs, or even provide client-side capabilities. The major benefit here is that these rule groups typically receive automatic updates and leverage the threat intelligence of these partners. Often, this means you get protection against new vulnerabilities even before they become publicly disclosed. That can be a significant advantage in staying ahead of zero-day exploits. Just one note. If you're using these with AWS Firewall Manager across multiple accounts, every account in your organization needs to subscribe to ensure that consistent policy application.
Okay, now, here's where things get seriously smart. Intelligent threat mitigation in AWS WAF. This is about moving beyond just simple pattern matching to detect more sophisticated adaptive threats, the kind that can cleverly bypass basic rules. AWS WAF offers three main intelligent protection packs here. First, AWS WAF Fraud Control Account Creation Fraud Prevention, ACFP. This is designed to detect and manage malicious account creation attempts right on your sign-up pages. Second, AWS WAF Control Account Takeover Prevention, ATP. This focuses on detecting and managing malicious login attempts on your login pages, trying to stop credential stuffing and brute force. And third, AWS WAF Bot Control. This helps you manage requests from various types of bots, everything from simple crawlers to advanced, persistent bots trying to scrape your data or commit fraud.
That sounds incredibly powerful, but it kind of begs the question, how exactly do these intelligent protections work under the hood? What's the magic? Well, a crucial element is AWS WAF tokens. Think of a token as a unique encrypted fingerprint of a single client session. It's a collection of information about the client stored securely in a cookie named OSWAF token, and it gets provided with every subsequent web request from that client. This token contains things like a timestamp of successful challenges, but critically it also contains what AWS calls non-unique client-side signals.
Non-unique signals, what does that mean?
Right. So these are indicators gathered from the client's browser or device. Things like, how consistent are their mouse movements? Does their browser have common plugins often used by automation tools? How quickly are forms being filled out? Individually, any one of these might not mean much, but collectively, they create this sort of fingerprint or profile. It helps WAF discern a real human from even a sophisticated automated bot, even if they're coming from the same IP address or trying hard to mimic legitimate traffic patterns. This sophisticated analysis makes it economically much harder, maybe unfeasible, for large-scale botnets to bypass these checks. Okay, so how does a client get one of these tokens? Token acquisition happens in a couple of key ways. You can configure a challenge or kept TCHA rule actions right in your web ACL. These automatically trigger the token acquisition process when a suspicious request is identified. Alternatively, for maybe a smoother user experience, you can use the AWS WAF application integration SDKs. These are available for JavaScript, Android, and iOS, but they require coding directly into your client application, so there's development effort involved.
Okay, so there's a trade-off there.
Exactly. The rule actions are easier to implement, just configure the rule, but they incur additional costs per challenge and can be more intrusive, especially if they pop up a key PTHA for the user. The SDKs, while requiring that dev effort, generally offer a better, often seamless user experience. And they're free to use, though they are always paired with the paid intelligent rule groups themselves. What's fascinating here, too, is how WA validates the token's domain. It has to match the protected resources host domain, like www.example.com. This ensures tokens aren't just spoofed or reused across different sites. And if you're using CloudFront, this is crucial. You absolutely have to configure CloudFront to forward the OSWAF token cookie to the origin. And WAF needs to recognize the CloudFront distribution's domain as a valid token domain, because the client browser sees the CloudFront domain, right, not your origins directly. Without those two pieces lining up, the tokens won't work properly with CloudFront. You'll end up challenging or blocking legitimate users.
Okay, let's give you some concrete examples of how these intelligent rule groups actually work to protect your business. For ACFP, that's Account Creation Fraud Prevention. It deeply analyzes fields and registration requests. Usernames, passwords, emails, phone numbers, address fields, looking for suspicious patterns. It also inspects the response codes from your application to understand success or failure indicators. Did the account creation succeed or fail? For example, a rule like volumetric session high can block high volumes of account creation requests coming from just a single session, maybe more than 10 requests in 30 minutes, indicating a bot farm trying to create fake accounts for spam or fraud. It's worth noting, too, the stolen credentials database used by ACFP, the one that identifies known compromised credentials, only contains usernames that are in email format, so keep that in mind. Imagine a small e-commerce store suddenly hit by a sophisticated botnet trying to create thousands of fake accounts. Before ACFP, this would just swamp their support team, skew analytics, maybe lead to financial loss. Now, WAF intelligently identifies and challenges or blocks these, preserving your legitimate user experience and keeping your data clean. Similarly, for ATP, Account Takeover Prevention, WAF inspects login requests, specifically looking at username and password fields, and also the responses from your application. It's looking for signs of credential stuffing or brute force attacks. An example rule here is attribute compromised credentials. This blocks requests using stolen credentials that the system identifies, often sourced from those large public data breaches we hear about. Another one, attribute username traversal, blocks multiple requests from the same client session that are just cycling through different usernames. That's a classic sign of a brute force or credential stuffing attack. There are also special CloudFront-only rules like volumetric to failed login response high and volumetric session failed login response high. These track high volumes of failed login responses coming from a single IP or a single session, another strong indicator of attack.
Right. And I recall hearing about a company, I think it was in the financial sector, that saved potentially millions in fraud losses just by implementing an intelligent ATP system like this. It caught sophisticated credential stuffing attacks that their basic firewall rules were completely missing.
Wow. Yeah, so it's not just about security theater, it's about real business impact. Absolutely. And when it comes to bot control, it cleverly distinguishes between common protection and targeted protection. Common protection identifies those self-identifying bots, think legitimate web scraping frameworks, known search engine crawlers like Googlebot, automated browsers that announce themselves via their user agent strings or other signatures. These aren't necessarily malicious, but you might want to manage them. Targeted protection, though, goes after the more sophisticated, non-self-identifying bots, the ones that often mimic human behavior precisely to avoid detection. This level requires advanced machine learning. Its rules, often named with TGTML prefix, need about a 24-hour baseline of your normal traffic to be established before they become fully effective. They need to learn what normal looks like for you so they can accurately differentiate between good and bad bot traffic. And once those baselines are set, these rules are continuously updated and adapted by AWS to try and outmaneuver evolving bot tactics.
Okay, so this raises a really important question. How do you actually get the most out of these powerful, intelligent threat mitigation features? Best practices are absolutely crucial here. First, always test and tune these rules rigorously. Do it in staging or non-production environments first. Then, when you go to production, deploy them in count mode initially.
Right, the safety net.
Exactly. This lets you monitor their behavior, see what they would block without actually blocking potentially legitimate traffic. You can identify any false positives before you enforce the block action. You typically review the rule match details in your WAF logs, identify patterns in legitimate traffic that are accidentally triggering your rule, and then craft exclusions or refine your match criteria. It's an iterative process, but that count action provides that vital safe feedback loop. When it comes to rule group placement within your web ACL, it's generally best to position these intelligent rule groups carefully. Often, they should go after your existing rules that detect and block known malicious traffic like SQL injection or XSS rules, but before any rules that explicitly allow known good traffic, like maybe from trusted partners. This prevents disruption to your current security posture and ensures the intelligent rules see the traffic you want them to analyze. And finally, customization is key. You can use label matching rules and custom responses to tailor how WAF handles identified threats. For instance, instead of just blocking a user whose credentials appear compromised, you could maybe return a custom error page with instructions on how to reset their password. Or you could add custom headers to allowed requests for downstream processing in your application, maybe flagging potentially suspicious but allow traffic for closer inspection later.
So thinking strategically, what does this all mean? This advanced layer of WAF protection, it's really about fighting fire with fire, but using intelligence, right? It allows you to use sophisticated machine learning and behavioral analysis to outmaneuver even the most persistent and adaptive bots and fraud attempts. This not only enhances your security posture, but it also significantly drives up the cost and complexity for the attacker. It makes large-scale automated fraud attempts much less profitable for them. You're no longer just blocking, you're actively deterring. And ultimately, it ensures your application remains available and secure for your legitimate users, safeguarding your reputation and, yeah, your bottom line. Okay, let's transition now from those specific application level threats where WAF really excels to a much larger, maybe more existential kind of beast, distributed denial of service or DDoS attacks. While AWS WAF acts as your application's bouncer, deftly handling malicious requests at that application layer, layer 7, DDoS attacks can target much deeper layers of your network. They aim to overwhelm your entire infrastructure or exhaust critical resources like bandwidth or connection tables. This is precisely where AWS Shield Advanced steps in. Think of it less like a bouncer and more like a massive, almost impenetrable fortress wall.
Yeah. And to really understand Shield Advanced, it helps to first contrast it with AWS Shield Standard. Shield Standard is an automatic protection feature. It's provided to all AWS customers at no additional cost. It gives you a foundational level of defense against the most common, frequently occurring volumetric DDoS attacks, things like UDP reflection attacks, TCP, SYN floods. It's a good baseline for everyone on AWS. AWS Shield Advanced, however, is a paid subscription service, and it offers significantly enhanced DDoS detection and mitigation across all three layers: the network layer, layer 3, the transport layer, layer 4, and the application layer, layer 7. Its benefits are substantial. You get things like guaranteed availability SLAs for your protected applications. You get rapid access to AWS's elite DDoS mitigation experts, the Shield Response Team, or SRT, during an attack. You get detailed real-time attack notifications. And crucially, you get cost predictability. Shield Advanced includes DDoS cost protection, which covers spikes in data transfer out or other service charges incurred because of a DDoS attack. That alone can save potentially millions during a large attack. Gives businesses huge peace of mind, even under severe duress.
Okay, so this multi-layered approach. What specific types of attacks does Shield Advanced actually mitigate?
Well, it's meticulously designed to protect against a wide range. First, network volumetric attacks, layer 3. These are the brute force attempts trying to saturate your network capacity. Think massive DNS query floods trying to overwhelm DNS servers, or UDP floods just filling the pipes. Second, network protocol attacks, layer 4. These exploit protocol vulnerabilities to exhaust resources on your servers or network devices. The classic example is a TCP SYN flood, which can exhaust connection states. And third, application layer attacks, layer 7. These flood your applications with seemingly valid but often resource-intensive queries, things like HTTP floods or cache-busting attacks that try to bypass edge caching and force every request directly to your origin servers, pushing them way beyond their capacity. Shield Advanced tackles all of these. So connecting this to the bigger picture, how exactly does Shield detect events across these different layers? AWS operates both service level and resource level detection systems. These are continuously monitoring traffic patterns, looking for anomalies. For the infrastructure layers, L3, L4, services like CloudFront and Route 53 have fully inline DDoS mitigation systems built right into the AWS network border and all the edge locations. These systems inspect all packets as they come in, but they're designed to introduce no observable latency, so your legitimate traffic isn't slowed down by the protection itself. Shield Advanced can also leverage Route 53 health checks in a clever way. If an application's health check suddenly reports unhealthy, maybe because an attack is just starting to ramp up, Shield Advanced might proactively place a mitigation even before its systems have full statistical confidence that it's a DDoS attack. This allows for faster, more accurate detection and helps avoid false positives later by quickly shunting suspicious traffic away early. And for application layer 7 protection, Shield Advanced seamlessly integrates with and utilizes AWS WAF, providing that unified view and coordinated defense across all layers.
Okay, detection is one thing, but once an attack is detected, how does Shield actually mitigate events? How does it stop the attack?
Right. For infrastructure mitigations, L3, L4, AWS Shield DDoS mitigation systems are distributed globally. There are all points of ingress from the internet across all AWS regions and edge locations. When an attack is detected, Shield intelligently reroutes the malicious traffic through these DDoS mitigation systems in the same location.
In the same location. Why is that important?
It's a key operational detail. It avoids rerouting traffic to external centralized scrubbing centers, which is what some other providers do. Rerouting externally can introduce significant latency for your users. By mitigating locally, AWS minimizes that impact. This geographically distributed approach gives AWS a massive mitigation capacity. They state over 100 terabits per second, TBPS, globally. That's far more than enough to handle even the largest known DDoS attacks. Shield dynamically determines the right mitigation capacity needed based on the resource type being attacked, but maybe an EC2 instance, an application load balancer, network load balancers with elastic IPs, or global accelerator. And it continuously adapts the rate limits based on real-time traffic ratios. This ensures effective mitigation without being overly aggressive and accidentally blocking legitimate users. For example, for application load balancers, Shield combines its DDoS mitigations with the load balancer's own automatic scaling capabilities. This creates a really highly resilient front door for your application. And the human element here is simply invaluable, the Shield Response Team, SRT. These are AWS's elite DDoS mitigation experts. They're available 24/7, but only to customers who subscribe to Shield Advanced and also have either the business or enterprise support plan. Their role is absolutely critical during an active attack. They proactively engage often. They'll reach out to you even before you fully realize the scope of what's happening. They analyze WAF logs to identify subtle attack characteristics, and with your approval, they can craft custom WAF rules in real time to mitigate offending traffic sources that maybe automated systems missed. They can also build custom network mitigations for infrastructure layer attacks, perform network traffic engineering to maybe allocate more mitigation capacity specifically to your affected resources, and provide architectural recommendations to help you better align your resources with AWS best practices for DDoS resilience before the next attack.
So you have to grant them access somehow.
Yes, exactly. Granting the SRT access to your account in ORF logs is done via specific IAM roles and policies. There's one AWS Shield DR Taxus policy, for example. This allows them to make the necessary API calls and access logs on your behalf, giving you expert hands on deck exactly when you need them most.
So wrapping up Shield Advanced, what does this all mean for you? It essentially provides a robust, expert-backed defense against even the largest and most sophisticated DDoS attacks. It's about ensuring your applications remain available and performant when it matters most. It gives you that peace of mind that you have a dedicated team and massive global infrastructure defending your digital front door. This allows you to focus on your core business rather than constantly battling relentless attackers. It's really a critical layer of business continuity.
Okay, moving into how these services interact, especially across an entire organization, let's talk about the critical integration of WAF with other AWS services. A primary and probably the most common integration point is Amazon CloudFront. You associate a WAF web ACL directly with your CloudFront distributions. This places that WAF bouncer right at the very edge of the AWS network, as close to your users as possible, filtering traffic before it even gets deeper into the network. Now, what's fascinating here is a crucial configuration step we touched on earlier, specifically for WAF's intelligent threat mitigation features that use tokens. CloudFront must be configured to forward the OSWAF token cookie to your origin. By default, CloudFront might strip out cookies it doesn't recognize to improve caching. So you need to explicitly configure your cache behavior settings in CloudFront to include this specific OSWAF token cookie in its allow list. Additionally, WAF itself needs to be configured to recognize the CloudFront distribution's domain, e.g. d123.cloudfront.net or your custom CNAME, as a valid token domain. Because, remember, the client's browser interacts with the CloudFront domain. But WAF, perhaps running closer to your origin, might by default only look at your origin's host header. Without getting both of these pieces right, forwarding the cookie and validating the correct domain, your WAF tokens won't function correctly with CloudFront. You could end up constantly challenging or blocking legitimate users. Another aspect of CloudFront integration involves custom error pages. If WAF blocks a request, it typically returns that HTTP 403 forbidden status code. You can configure CloudFront to catch these 403s and display a custom error page instead. This helps maintain a consistent user experience and branding rather than showing a generic, ugly error. However, an important distinction to remember: if you define WAF custom responses directly within your WAF rules, maybe returning a specific status code like 403, but also custom headers or even a custom HTML body, those WAF custom responses will override any custom error page configurations you have in CloudFront for that particular status code. WAF-specific rule action wins. Also, a subtle but important point: CloudFront itself cannot distinguish why it received a 403. Was it from WAF blocking the request, or was it from your actual origin application returning a 403 for some other reason? So you can't have different CloudFront custom error pages based on whether WAF or the origin generated the 403. It just sees the 403 status code. Now, if we connect this to the bigger picture, especially for organizations with multiple AWS accounts, which is pretty much standard for enterprises these days, AWS Firewall Manager becomes almost indispensable. Firewall Manager centralizes the management and deployment of WAF policies and also Shield Advanced Protection policies across all accounts within an AWS organization's structure. So central control across the whole company. Exactly. It's incredibly powerful for maintaining consistent security across your entire enterprise footprint. For example, a central security team can define a master WAF policy. This policy might include pre-processing rule groups, enforcing a mandatory baseline of security for common threats across all accounts. It could also include post-processing rule groups for things like organization-wide logging standards, or maybe some advanced threat detection rules managed centrally. Then, local account owners or individual application teams can add their own specific rules in between these centrally managed pre- and post-processing groups. This allows them to tailor protection for their unique application needs while still being forced to adhere to the organization-wide baseline set by the security team. Firewall Manager simplifies enforcement, helps ensure all your resources get protected according to your defined security posture, and allows for rapid onboarding of new applications or teams while maintaining that crucial central control and compliance overview.
Okay, that makes sense for large setups. Let's talk about monitoring and logging. Because knowing what's happening to your traffic, ideally in real time, is absolutely critical for effective security, right? You can't protect what you can't see.
Absolutely vital. And both WF and Shield Advanced integrate seamlessly with Amazon CloudWatch to provide near real-time metrics. You get immediate dashboards showing things like total request counts, how many requests were allowed versus blocked by which rules, and even WebACL capacity unit, WCU usage for WEF, which helps you manage costs and understand rule complexity impacts. During a DDoS event, Shield Advanced takes this a step further. It reports its DDoS-specific metrics much more frequently, typically once per minute, compared to its less frequent reporting during normal periods. This rapid feedback loop during an attack is essential for understanding the scale and characteristics of what's hitting you, allowing for a much faster, more informed response, maybe involving the SRT.
Okay, metrics give you the overview, but what about seeing the actual requests?
Right. For that, web request sampling in BOF provides invaluable insights. It gives you a sample up to 100 actual web requests that match specific rules within the last 3 hours, and another 100 samples for requests that triggered the default action, usually allow or block. This is incredibly useful for understanding why a particular rule is matching certain traffic and for debugging potential false positives without having to sift through massive log files initially.
And for the really deep dive, you need full logs.
Exactly. For comprehensive analysis, logging in WAF is key. You can configure WAF to send detailed WebACL traffic information to Amazon Kinesis Data Firehose. Firehose then acts as a delivery stream, sending these logs to various destinations. Common choices are Amazon S3 for long-term archival and analysis using tools like Athena, or to CloudWatch logs for near real-time monitoring and alarming, or even streaming them to external security information and event management, SIEM systems like Splunk or Sumo Logic for deeper threat hunting and correlation with other security data. These detailed log entries contain crucial information. Timestamps, the web ACL ID, the specific terminating rule that took action, the action itself, allow, block, count, etc., the client IP address, full request headers, the URI, and any labels applied by rules, especially useful with managed rules and intelligent threat detection. Gives you a complete picture of every evaluated request.
That sounds like a lot of data, potentially sensitive data in headers or request bodies. What about privacy?
Excellent point. And crucially, for handling sensitive information, WAF offers powerful data protection in logs. This feature allows you to configure WAF to permanently transform sensitive data before it even gets written to your logs. You can choose to either hash specific header keys, like maybe an authorization header, or substitute parts of the request body, particularly within the rule match details field that shows why a rule matched. This protects privacy and helps meet compliance requirements like GDPR or HIPAA, while still maintaining the utility of your logs for security analysis because you can still see that something matched, just not the raw sensitive data itself. It's about logging effectively without compromising data privacy. Okay, this brings us to a really fundamental concept. Who is responsible for what when it comes to security in the cloud? This falls squarely under the AWS shared responsibility model. AWS's responsibility is defined as security of the cloud. This means AWS is responsible for protecting the underlying global infrastructure, the hardware, software, networking, and facilities that run all AWS services, including WAF and Shield. The physical data centers, the network architecture, the hypervisors. Your responsibility, on the other hand, is security in the cloud. This means you are responsible for how you use those services securely. Specifically for WF and Shield, this means configuring and managing the services correctly, defining your rules appropriately, protecting your data within these services, like managing those logs, and crucially, managing identity and access.
So AWS provides the castle walls, but you're responsible for arming the guards and managing the gates.
That's a perfect analogy, exactly right. And that brings us to IAM, or Identity and Access Management. It is absolutely paramount here. It controls who can do what with your WEF and Shield resources. Authentication is about how you sign in. Are you using the root user account, which should be locked down and used very sparingly, always with MFA? Are you using IAM users, or are you assuming IAM roles, maybe for temporary credentials? Multi-factor authentication, MFA, is strongly recommended for all users, especially privileged ones, to add that critical extra layer of security. Authorization, on the other hand, is defined by IAM policies. These are typically identity-based policies written in JSON format attached to users or roles. These policies specify precisely which actions an identity is allowed or denied to perform, like WAF2.getWebACL, WAF2.update rule group, Shield, create protection. They also specify which specific resources these actions apply to, identified by their unique Amazon resource names or ARNs. The ARN format includes the service, region, account ID, and resource details. Example, arn.as.wafi2.useast-1.12345. 6789012.globalbackly.webawkwoo. Remember, for WAF resources used with CloudFront, which is global, the region in the ARN is always US East 1. For WAF resources protecting regional services like AOBs or API gateways, you use the specific region you're operating in. Policies can also include conditions, adding further constraints.
And what about those service-linked roles you sometimes see?
Right. Service-linked roles, like AWS Service Role for YFE2 logging, are special IAM roles that are pre-configured by AWS. They grant specific permissions to an AWS service, like GoBUF, allowing it to perform actions on your behalf, in your account in this case, allowing WEF to publish logs to Kinesis Firehose. You typically don't manage the permissions on these roles directly, and you can't change their names, but you can manage their descriptions and deletion if the service no longer needs them. They simplify granting necessary permissions between services.
So wrapping this all up, what does this shared responsibility model in IAM mean for your organization in practice? It's really about building strong, defensible applications within a clear framework of responsibility. AWS provides the incredibly robust castle walls, the underlying highly resilient infrastructure for WAF and Shield. But you are responsible for arming the guards by writing effective rules, setting the precise policies at the gate using WAF, managing who has the keys to the castle using IAM, and continuously monitoring what's happening through logging and CloudWatch. That's a powerful partnership, ultimately aimed at ensuring your digital assets are as secure and resilient as possible against the constant barrage of online threats. Wow. Okay, we've journeyed through the intricate and, frankly, incredibly powerful world of AWS WAF and Ashe Shield Advanced and AWS Firewall Manager. It's abundantly clear these aren't just isolated tools, they really are a sophisticated, interconnected ecosystem. They're designed to give you peace of mind and maintain that crucial business continuity in what feels like a constantly evolving, often hostile threat landscape.
From fine-tuning exactly who accesses your application with the granular control of WAF rules to intelligently combating sophisticated bots and fraud attempts with WEF's advanced intelligent threat mitigation. And finally, standing strong against even the largest, most overwhelming DDoS attacks with Shield Advanced and the expert backing of the Shield response team. You should now have a pretty comprehensive understanding of how to protect your digital assets on AWS.
Absolutely. And remember, the true power of these services lies not just in their individual capabilities, but really in their synergy, how they work together to provide multi-layered defense. AWS WAF and AWS Shield Advanced work hand in hand. WAF provides that crucial Layer 7 defense against application-specific threats, while Shield Advanced guards the broader network and transport layers against those massive DDoS floods. And tying it all together, especially for larger organizations, AWS Firewall Manager acts as the orchestrator, the conductor for this symphony of consistent security policies across your entire organization's accounts, ensuring unified defense and rapid compliance.
So, for your next step, as you think about all this, consider this provocative thought. In a world where automated threats are becoming increasingly sophisticated, increasingly adaptive, how can proactively integrating and continuously adapting these defensive measures, WAF rules, shield protections, intelligent threat detection, become not just a cost center, but a fundamental competitive advantage for any online presence? Think about it. It's not just about protection anymore. It's about building resilience, maintaining user trust, and ensuring uninterrupted business continuity in an increasingly hostile digital environment. That trust, that resilience, maybe that's the real competitive edge. We certainly hope this deep dive has given you some truly valuable insights and maybe a clearer path forward in securing your applications on AWS. Until next time, stay well informed and stay secure.